low. Let's do the homework problem. So we have a pump rotating at 1200 rpm in the direction shown. This would be negative direction, right? Because we said the counterclockwise is the positive direction in an XY plane. The exit velocity is v2, absolute velocity, and it's making 30 degree with the radial direction, and that value is 90 degree. And you want to calculate the torque, and you give us the dimensions over here. So to calculate the torque, you should always think about one equation for turbo machine. What's that equation? Torque equal m dot r2 v theta 2 minus r1 v theta 1. Here, this is the equation that we're going to use to calculate the torque. First, let's write what's given to us, and we said we use this place to write the right dimension. So when he said omega is 1200 rpm, we don't write rpm, we write multiply by 2 pi over 60 radian per second. We need the density because the m dot, you know that, right? So we need to get the density from somewhere. Look at the book, find it from the internet. So rho for water is 1.94 slugs per feet cube. As I said in class, we don't use pound mass, right? So it should be slugs per feet cube. And V1 is all radial. That make V1 theta, the tangential component of V1, 0, right? If V1 is all radial coming in, and why wouldn't it be all radial, right? Because it's being sucked into the turbine, in the pump, and then it will basically go everywhere radially inward because of the suction created by the rotation. Now V2 theta is this guy. So if V2 is here, you can split V2 into a radial component that go to the center and a tangential component. So obviously this V2 theta is V2 sine 30 degree. Now what's with the negative sign? Well, the negative sign because it's in this direction, and again this direction is the negative rotational direction. Okay, so that's why you see V theta 2 or V2 theta is minus V2 sine 30 degree. Alright, so R2 V theta 2 is here. We need the m dot. What's the m dot? We can do it at the inlet or at the outlet. Maybe we should do it at the outlet since we know the velocity at the outlet. So m dot is always rho time area time of velocity. Rho, we got it. Area, that would be this strip over here. If you open this, you will end up with a long strip that has width of h, that width, and a length of the circumference 2 by r2h. Okay, multiply by what velocity? The velocity normal to the area, and we said it should be the radial component of V2, so that's why it's V2 cosine 30. Why did we do V2 cosine 30? Because it's normal to the area. So here is my m dot, rho a v, and here is r2 v theta 2 and r1 v theta 1 is 0 because it's all radial. I plug in the number and I get myself 890.7 pound foot. Okay, now interesting, the negative sign too. Where is it coming from? It's negative sign coming from this. What does that mean? It means that the torque also in the clockwise direction. So the torque and the omega are in the same direction. And I'm saying over here that makes sense because it's a pump. So if it's a pump, then the torque is the one coming from the shaft, and it's the one that basically helps the pump spin, right? So if in case of the pump, the torque is driving the pump, and so it makes sense that the torque and the omega are in the same direction. Okay, good job, thank you.